Hey everyone, welcome back to The Explainer. So today, we're taking a really rapid-fire tour of one of the most incredibly diverse land masses on the entire planet, India. And we're going to look at its epic geography, not just as lines on a map, but as a literal masterpiece of structural engineering. All right, let's just dive right in.
So picture a totally blank whiteboard. How exactly do you build a subcontinent? Like, if you were the ultimate architect, how would you construct India from the ground up? It sounds super complex, I know, but if we look at the source material, it actually breaks it down brilliantly. To really make this stick, I want you to think of India as a grand fortress. See, this isn't just some random collection of rocks. It's this beautifully structured, heavily fortified geographical castle. Just keep that image in your head as we build this thing out top down.
The 5 building blocks of India. 1. The Himalayas. 2. The North Indian Plains. 3. The Peninsula. 4. Coastal plains. And 5. Island groups. Now, for today's quick session, we're really just going to zoom in on the primary 3 that form the absolute core of our fortress.
Okay, let's start right at the top with the Himalayan walls. Imagine drawing this massive sweeping wall of stone and ice, stretching all the way from Jammu and Kashmir in the west, straight across to Arunachal Pradesh in the east. That right there is the impenetrable northern barricade of our fortress.
But here's the thing. The Himalayas aren't just one single wall. They're actually a series of parallel barricades. Stepping up from south to north, we hit the youngest ranges first, the Siwaliks. Then we move up to the lesser Himalayas, getting higher into the greater Himalayas, also called the Himadri, and finally, way up there, the oldest trans-Himalayan ranges in the far north.
Dropping straight down from those massive mountain walls, we enter the inner bounds of our fortress, the fertile courtyard, otherwise known as the North Indian Plains. Wedged right below the mountains, this huge, flat, low-lying area is basically the bustling agricultural heart of the entire subcontinent.
Now, our courtyard is actually split right down the middle by the Aravalli Ranges. To the east of that, you've got the incredibly lush Ganga Plains sloping off to the east. But over on the west, that's where you hit the massive Thar Desert and the super fertile Punjab Plains, which are formed by the river Sutlej sloping westward.
And when the massive rivers of this courtyard finally meet the sea, they create some absolute geographical marvels. Formed by the huge Ganga-Brahmaputra system across India and Bangladesh, the Sundarbans is considered the world's largest delta. It's like our courtyard literally spills right out into the ocean.
So a wall and a courtyard, right? They need a solid base. Enter the peninsula, which is just an area of land tapering towards the ocean. Lying directly south of the plains, this is the ancient, basically unshakable stone foundation holding up our entire fortress.
You have got to check out this geological time gap. Up north, the Himalayan walls are what we call young fold mountains. But down here on our peninsular foundation, those are the Aravallis, the oldest fold mountains. The youngest and the oldest rocky architectures sharing the exact same subcontinent. It's kind of mind-blowing when you think about it.
And as this land tapers south, this sturdy base is made of some seriously rugged foundation stones. We're talking a vast series of plateaus, the central Vindhyas and Satpura ranges, all flanked by the protective, hilly rims of the western and eastern Ghats.
So, let's just bring this whole thing together. You've got the towering Himalayan walls guarding the north. Then, the massive, life-sustaining courtyard of the northern plains sitting right in the middle. And, supporting the whole shebang, that deep ancient stone foundation of the peninsula.
Welcome back to another Explainer. Today we're setting off on a truly massive thematic expedition. We're going to break down the physical landscapes of 2 of the most geographically diverse and honestly just colossal nations on Earth, India and Brazil. We aren't just looking at flat maps today. We're getting into the literal bones of these land masses to understand how their mountains, plains, and coasts are structured. It is a fascinating side-by-side study in sheer scale and physical contrast. So let's get into it. Okay, let's dive into this. Here's our roadmap for today. 1. High grounds and escarpments. 2. The vast inland plains. 3. Contrasting the coastlines. And 4. Exploring the island groups. Now, when you do even a quick study of these 2 countries, a pretty stark contrast immediately jumps out at you. Brazil is overwhelmingly dominated by these expansive highlands, plateaus, and ancient shields. India, on the other hand, presents highly distinct features framing its peninsula. Most notably, its remarkably dissimilar coastal plains and really rich island groups. Let's unpack exactly what that means on the ground. All right, Section 1, High Grounds and Escarpments. the ascent. So here's a kind of surprising fact if you're used to geographies dominated by massive things like the Himalayas or the Andes. Brazil doesn't actually have very high, long-extending mountain ranges. Instead, the core of the country, and really the core of the entire South American continent alongside the Guyana highlands, is made up of an extensive plateau. Southern Brazil is just occupied by this vast Brazilian shield. And from this high ground, the land mostly just slopes gently towards the north, feeding countless little tributaries that eventually turn into rapids and waterfalls as they make their way down. But while it lacks long mountain chains, it does have one very distinct peak. Pico de Neblina reaches an altitude of exactly 3,014 meters. That is the absolute highest peak in Brazil. But get this, it doesn't sit deep in those central plateaus. You actually have to go way up north to find it, sitting squarely on the border between Brazil and Venezuela as part of the Guyana highlands. Now, contrast that high peak with a sudden, drastic drop of 790 meters. This is a crazy, fascinating feature called the Great Escarpment, and you'll find it on the eastern side of the Brazilian highlands. Even though it occupies a relatively small total area, this escarpment acts like a giant, steep wall just battling the elements. Particularly between Sao Paulo and Porto Alegre, the drop is incredibly steep. And this brilliantly illustrates how physical terrain directly controls the climate. Because of that steep 790-meter wall we just talked about, the Great Escarpment acts as a literal physical barrier to the southeast trade winds coming right off the ocean. The winds hit the wall, they drop all their moisture, and leave the region to the north and northeast completely dry. This creates a massive rain shadow area known as the drought quadrilateral. Think about that. One geographic wall single-handedly creates an arid zone in an otherwise lush tropical country. Moving right along to Section 2, the vast inland plains, the descent. So, as we move down from the highlands, we find that the plains in Brazil are mostly confined to two main areas. The most famous one, of course, is the Amazon basin in the north. The Amazon plains basically act like a giant geographical funnel. Out in the west, they are incredibly wide, stretching about 1,300 kilometers across. But as you move eastward, the Guyana highlands from the north and the Brazilian highlands from the south literally start to close in like a vise. They squeeze the plain down to a width of just 240 kilometers. Then, as the river finally pushes past this choke point and gets closer to the Atlantic Ocean, the plains widen out once again. It's an incredibly dynamic, heavily forested landscape that's honestly largely inaccessible just because of the frequent flooding. The other major plain region is located down to the southwest of the highlands, forming the source region for the Paraguay and Parana rivers. Here you'll find the Pantanal. And listen, this isn't your typical grassy plain. It is one of the absolute largest wetlands in the entire world. It's this vast region of swamps and marshes located in northwestern Mato Grosso do Sul, extending all the way into neighboring Argentina. It's a complete, stark contrast to the dense tropical rainforests of the Amazon plain. All right, Section 3, contrasting the coastlines, the edge. Now, what's really interesting about this is when we bring India back into the picture, we see a sheer dichotomy in its coastlines. They are remarkably dissimilar. The western coast, bordering the Arabian Sea, is rugged, jagged, and rocky. Spurs from the Western Ghats extend right up to the water, and because the terrain is so steep, the rivers here are short and swift, literally carving out estuaries rather than deltas. But the eastern coast bordering the Bay of Bengal, completely different story. This is a coast formed by deposition. The land slopes gently, so rivers flowing east naturally slow down, dropping all their sediments right at the coast. The result? Beautiful, sprawling deltas. It's one peninsula, but you're getting two completely different physical behaviors at its edges. And the sheer scale of this coastal edge is staggering. India is blessed with approximately 7,500 kilometers of coastline wrapping around its peninsula. That is a massive border defined entirely by oceanic interaction. But here is where the comparison gets super fun. Brazil's coastline is nearly identical in length, measuring in at about 7,400 kilometers. Brazil divides this massive stretch into two main parts, the northern coast, which is a low-lying region totally dominated by the mouth of the mighty Amazon, and the eastern coast, which receives a large number of much smaller rivers, with the São Francisco being the only really major one meeting the Atlantic down there. And Brazil's coastline isn't just long. It literally holds world records. At the southernmost tip of the Brazilian coast, on the South Atlantic Ocean, is Praia do Cassino, or Casino Beach. It is considered the longest sandy beach in the world. It stretches continuously as a sandy shore for over 200 kilometers. Literally, just imagine trying to walk that entire length. Okay, final stretch, Section 4, exploring the island groups. Moving entirely off the mainland, let's look at India's offshore footprint, which perfectly mirrors the crazy contrasts of its coastlines. In the Arabian Sea, you've got the Lakshadweep Islands. These are mainly atolls, so low-lying, coral-based, and pretty small in extent. But swing over to the Bay of Bengal and you hit the Andaman and Nicobar Islands. These are much, much larger, featuring rugged hills right in their interiors. The Andaman group is actually primarily volcanic in origin. In fact, one of them, Barren Island, holds the title for having India's only active volcano. Brazil, meanwhile, classifies its islands a bit differently. They go by origin and distance from the shore. So they have coastal islands, which, much like India's eastern coast, are formed by deposition right near the mainland. But then they have their marine islands. These guys sit more than 300 kilometers out into the vast Atlantic Ocean. And what's incredible is that these aren't just floating rocks. They are actually the rocky, jagged peaks of massive submerged underwater mountain ranges, just barely peeking through the ocean's surface. And closer to the South Atlantic coast, they've also got their own coral atoll formations. Welcome to an epic geographic showdown. Today, we're pitting two absolute titans of the natural world against each other in this explainer, the Amazon and the Ganga. We're going to find out which river actually rules the world, exactly why the Amazon defies the laws of nature, and take a deep dive into Earth's biggest water funnels. Let's jump right in. To kick things off, try to wrap your head around this number. 70 log 50,000 square kilometers. That is the sheer size of the Amazon River's total catchment area. It's absolutely massive. But, what does a number that gigantic actually mean for the Earth? Well, to answer that, let's look at Section 1, Brazil's mighty drainage basins. Looking at the layout of South America on the whiteboard here, you can see Brazil is totally dominated by three huge river networks. Up top, you've got the sprawling Amazon basin. Down in the southwest, there's the Paraguay-Paraná system, and cutting right through the eastern highlands is the São Francisco River. It's just this incredible, interconnected web of water powering the whole region. And the Amazon itself? It's completely wild. It collects its headwaters all the way from the Andes Mountains in Peru, right? So it builds up so much speed and power that it blasts these huge sediment loads straight out into the Atlantic Ocean. The water is moving so violently, it literally stops a traditional delta from forming. Instead, it tears open a river mouth 150 kilometers wide, just packed with islands. Moving right along to Section 2, India's Himalayan and Peninsula rivers. Now, pivoting across the globe to India, we see a completely different kind of setup. Geographically, India's river system is basically split into two distinct parts. Up north, you've got the perennial Himalayan rivers, like the Ganga and the Indus. These guys flow year-round because they're fed by melting glaciers. But down south, you have the peninsular rivers, like the Godavari and the Narmada. These are entirely seasonal and rely super heavily on the monsoon rains. So how do we actually compare these two wildly different beasts? Well, to truly grasp their scale, we have to talk about catchment areas, which brings us to the giant funnel analogy. Think of a catchment area exactly like a giant rainwater funnel placed over a region. Every single drop of rain or piece of melting snow that lands inside that funnel eventually slides down into the main river channel. That is your catchment area. Now, the Ganga's funnel is incredibly vast, covering over 1 million square kilometers. But the Amazon's funnel? It is literally the size of an entire continent. Which brings us to Section 3, the ultimate Amazon versus Ganga comparison. When you stack the hard data side by side, the sheer scale is staggering. The Ganga is a massive 2,525 kilometers long, but the Amazon, it stretches out to 6,400 kilometers. And that catchment funnel we just talked about, the Amazon's is nearly 7 times larger than the Ganga's. It's not even close. But guys, the real knockout blow here is the discharge rate. That's how much water physically pushes out into the ocean. The Ganges discharges a really impressive 16,648 cubic meters of water per second. But the Amazon, it violently pushes out over 200,000 cubic meters of water every single second. That is a mind-blowing difference, and honestly, it crowns the Amazon as the undisputed king of rivers.